Hi, welcome to solveandgo.com. The next video is the next in a series of solutions to the MAT135 final exam from 2009. This is question number 16. Okay, so question number 16, what we have is, it's a question about limits and L'Hopital's rule. Given that the limit as x goes to 1 of ax4 plus bx cubed plus 1 over x minus 1 times sine of pi x. So given that this exists and is finite, find its value. Find its value. Okay, so we're told this limit exists. If you plug x equals 1 in, we get, so plug in x equals 1. That's usually the first step. So we get a plus b plus 1 divided by 1 minus 1 times sine of pi, which is a plus b plus 1 over 0. So given that this limit is finite, a plus b plus 1 can't be a non-zero number, because if it were, that means the value of this limit would have to be plus infinity, plus or minus infinity, because any non-zero number over 0 gives us plus infinity. So we're told that's not the case, so that means a plus b plus 1 must be 0. Okay, so we must be in the case where L'Hopital's rule applies. Okay, we get a finite number back. Okay, so let's use L'Hopital's rule. Okay, we're going to keep the fact that a plus b plus 1 is 0. Okay, so using L'Hopital's rule, we get, L'Hopital's rule, we get the limit as x goes to 1 of 4a x cubed plus 3b x squared divided by, so it's the derivative of the first factor, which is 1, times sine of pi x, plus the derivative, so the first factor times the derivative of the second factor, which is going to be cos of pi x, and then times pi, because you differentiate pi x. So we get a pi out here. And then what we see when we plug into the denominator is that this equals 0. Okay, so circle this here. This equals 0 at x equals 1. So the denominator again is 0, okay, because sine of pi is 0. And then when you plug, sine of pi is 0. And when you plug x equals 1 in, x minus 1 becomes 0. So again, this must mean that the top is non-zero for the exact same reason. Okay, we get a finite number, so L'Hopital's rule must apply, which means the top must be 0. So we get another equation. 4a plus 3b is 0. Which means we can solve for a and b. We have two equations with the two unknowns a and b. So let me go ahead and solve for those. Okay, up here we have 4a plus 3b is 0. And then in terms of solving, I'm going to rearrange the second equation and multiply it by 4. So we get 4a plus 4b is negative 4. So again, that's rearranging this second equation. Put a negative 1 on the right-hand side and multiply everything by 4. You'll get the second equation here. That allows us to subtract these equations and eliminate the variable a. We get negative b is negative 4. Sorry, we're subtracting, so negative b is 4, which means b is negative 4. Okay, and then we plug in and solve for a. So let's use, say, the first equation. 4a plus 3 times negative 4 is 0. So 4a must be 12, and a must be 3. So we've now solved for a and b. A is 3, b is negative 4. Let me go back to our expression from before. So we're going to keep those values. B is negative 4, a is 3. So we had our limit after L'Hopital's rule is, okay, so we took L'Hopital's rule, and at the same time, I'm going to fill in the values of a and b. So we get 4a cubed, sorry, a times x cubed plus 3bx squared divided by sine of pi x plus pi times x minus 1 cos of pi x. And then plugging in for a and b, remember we got b is negative 4 and a is 3. So we get that this is the limit as x goes to 1. A is 3, so that's 12x cubed. B is negative 4, so we get minus 12x squared divided by sine of pi x plus pi times x minus 1 cos of pi x. Okay, so we solved for a and b in the previous step, and now we've plugged it in to our function after applying L'Hopital's rule once. So now you plug x equals 1 into the numerator and denominator, and again, well, we knew this from before, but we verify that we get 0 on the top and 0 on the bottom. So we need to apply L'Hopital's rule one more time. What we get, so L'Hopital's rule, take the derivative of the top, we get 36. I'm going to run out of room here. Let me write this up top. Okay, so we get the limit as x goes to 1 of 36x squared minus 24x divided by the derivative of the bottom. Derivative of sine is cosine, so it's going to be pi times cos of pi x, okay, plus the derivative of the first term times the second over here when we use the product rule. So the first term is x minus 1. Its derivative is 1. So for the first part of the product rule, we get pi times cos of pi x. And then for the second part, we're going to end up with the first term, which is x minus 1, times the derivative of the second term. So cos goes to negative sine of pi x. Let me see if I can squeeze this in here somehow. Okay, so what we get, so I'll just write, instead of writing it in steps, I'll just write out what you get when you apply the product rule to this, when you differentiate the second term. So you get minus pi squared. So the extra factor of pi comes from taking the derivative of what's inside cosine. And you get times x minus 1 sine pi x. Okay, so I hope you can see that. So that's sine of pi x there on the right-hand side. Now when you plug x equals 1 in, what you get is 36 minus 24 divided by, so cos of pi is negative 1, so you get negative pi here, negative pi here, and then this last term is 0 because x minus 1 is 0 when x is 1. And finally, you get 12 over negative 2 pi, which is negative 6 over pi. And that's the solution and answer to question number 16.